Welcome to Ask and Learn.
So we're going to be using mathematical induction. We'll start off just by testing n equals 1. So that's the base case. We see when we do that, we end up getting the summation of j equals 1 to 1 of j to the fourth. And that's equal to this right here. So if we look here, we don't know if this is equal, but we see that this would be the summation of just 1 to the fourth, so that's just 1. And then that's going to be equal to 1 times 2 times this right here would be 3 times 3 plus 3, which is 6, minus 1 is 5 divided by 30. We see that this right here is 30 divided by 30, which is just 1. So the base case checks out. And then we want to assume that n is true, and then we're going to test n plus 1. So when we test n plus 1, we have the summation from j equals 1 to n plus 1 of j to the fourth. So what we have there, we want to see also n plus 1 times n plus 2 times 2n plus 3. And that's going to be times a pretty large polynomial here. That'll be 3 times n plus 1 squared plus 3 times n plus 1 minus 1 over 30. So we see with j to the fourth, we'll have all these values, and then the last one will be plus j to the fourth. So we know that n already equals all of those things. So we're just more focused on the n plus 1 aspect of it. So this right here is going to be n squared plus 3n plus 2 times 2n plus 3 times 3n squared plus 6n plus 3 plus 3n plus 3 minus 1 all over 30. We'll simplify this even further, so we'll get 2n cubed plus 3n squared plus 6n squared plus 9n plus 4n plus 6. And this is all going to be multiplied by 3n squared plus 9n plus 5 over 30. We'll combine these like terms up here, so we'll have a 3n cubed plus 3, we'll have a 9n squared plus 13n plus 6 times 3n squared plus 9n plus 5 over 30. And then we'll have to multiply this through one more time. So what we end up getting is going to be (9n to the 5th plus 27n to the 4th, and this is going to go on and on until we get over 30. And ultimately, once we multiply all these things out, we see that this is the same thing as if we were to take n plus 1 to the 4th and add it and take the summation of that with all the other values. So for that reason, we see, based on the base case and the n plus 1 case, using mathematical induction, we see that the equality holds true whenever n is a positive integer.